we're going to look at example 5b on page 128. Example 5b is actually quite a bit like 5a that the previous video was about. So again, we have a function given as 1 over 1 plus 2x to the fourth. And the question is, we want to find the power series expansion centered at a equals 0 for this function. And we're going to use the same method as we did in the previous video. We're going to look at this and try to decide if there is a function whose power series we already know that we can use here. And looking at this, it's not too surprising. We are going to look at 1 over 1 minus x again, because that's basically the structure we're looking at. And so remember that that's 1 plus x squared plus x cubed, and so on. Nice series. Now, what do we need to plug into, substitute in for x into this power series to get 1 over 1 plus 2x to the fourth? You want to rewrite it so that it's 1 over 1 minus something. And so what does that something have to be? Well, we have plus 2x to the fourth. We want minus, so that means we need another minus to overall get a plus when we multiply this out. And then it's just the 2x to the fourth. So we can write 1 over 1 plus 2x to the fourth as 1 over 1 minus 2x to the fourth. And now we write down what we had before. So we have 1 plus something squared plus something cubed plus something to the fourth, and so on. And that something is minus 2x to the fourth. So we have 1 plus minus 2x to the fourth plus minus 2x to the fourth squared, quantity squared, minus 2x to the fourth quantity cubed, and so on. And this is true. Again, we have to pay attention to the interval of convergence. The original one was true for x between minus 1 and 1. And so our new power series is valid for minus 2x to the fourth between minus 1 and 1. Okay, we can clean this up a little bit. And so we get 1 minus 2x to the fourth plus 2 squared x to the eighth minus 2 cubed x to the 12th plus, what do you think? Following the pattern, we're going to get a 2 to the fourth, x to the 16th. And then we would have a minus, and so on. And so this is our series. We also want to pay some more attention to the interval of convergence. So let's look at that. I'm going to actually start over. I have minus 1 is less than minus 2x to the fourth minus 1. This is what we have. And I want to solve for x. I want to describe for what values of x this series is true, converges, the series converges. And so let's see. There's a minus in front of the 2x to the fourth. So I'm going to multiply everything by minus 1. So times minus 1 times minus 1 times minus 1. And when you multiply an inequality by a negative number, you are flipping the inequality over. So you get 1 is greater than 2x to the fourth is greater than minus 1. Okay. All right. So, well, I can still write it the other way around. I would like my small numbers to be on the left just for consistency. So I have minus 1 is less than 2x to the fourth is less than 1. And now I can divide every part by 2. That gives me minus 1/2 is less than x to the fourth is less than 1/2. And so what do I have? I have that x to the fourth is between minus 1/2 and 1/2. I can rewrite that as the absolute value of x to the fourth is less than 1/2. And that tells me that I can rewrite that one more time as the absolute value of x to the fourth is less than 1/2. And now I can take the fourth root. That gives me the absolute value of x is less than 1 over the fourth root of 2. And so that I can rewrite. I can leave it like that. That would be fine. Or if you prefer to see it in the 3-part version, you can say that x is between minus 1 over the fourth root of 2. That's less than x is less than 1 over the fourth root of 2. Okay, so our final answer, what's our final answer? Our final answer is that our power series can be written like this. Our function as a power series can be written like that, and the interval of convergence is minus 1 over the fourth root of 2 to 1 over the fourth root of 2. That is our interval of convergence.